everyone. Let us look at this round robin scheduling algorithm. Okay, so here the process are going to be executed for a fixed amount of time called as quantum. Okay, so every time a process comes in from the ready queue, that will be executed for a fixed time, and then it will be preempted to execute the other process which is in the ready queue. Clear my point? So it will be executed based on the arrival of based on the processes that are in the ready queue, and every process will be executed only for a fixed period of time irrespective of their burst times. Okay, so let us look at this example now. We have like four processes with their burst times, and we are assuming that the time quantum is 5 milliseconds. Okay, so we have something like here the burst time, the same thing I am taking here. Okay, let me show the Gantt chart here. All right, so now you see there is no arrival time given here, so that means we assume that all the processes have arrived at the 0 milliseconds, and here we have something like a ready queue. Now this is a ready queue. Okay, and we assume that all processes in serial order has arrived here. P1 has arrived, and then P2 has arrived, and P3 also has arrived, and P4 has arrived here. Okay, so now 0. So first P1 is in the ready queue, so P1 will be scheduled here, and it will run only for fixed amount of time, that is 5 seconds. So it will run only 5 seconds. Okay, so now how much time remaining for P1? Only 5 seconds have been done, so 16 is remaining here now. Okay, so now at this case at 5 milliseconds after finishing for P1, okay, that state of this process will be saved here in the PCP, and then it will be scheduled for execution after all the processes. Yani it will be in the queue now, again P1, and P2 will be taken up here for execution. P2 will be scheduled for execution. Again this will also run for 5 seconds, but you see P2 has only 3 seconds here, so it will complete its job at 8 milliseconds. Okay, and it has completed its job, so here I'll remove it from the queue. Okay, I'm not rescheduling it here, just like I scheduled the P1 here. I'm not rescheduling the P2 into the ready queue because P2 has completed its job here. Okay, now what is there in the ready queue? P3 is there in the ready queue, and again this will also execute for 5 seconds, that is quantum as 5, so it will execute for 5 seconds because we have total burst time is 6, so it will execute for total quantum time, that is 8 plus 5, it's going to be 13. All right, so how much time left here now? 1 millisecond is left for process P3 to complete here. Okay, so what I will do, I will remove this from the ready queue, and this will come after P1 again. Okay, so now P4 will be scheduled. Now when P4 has been scheduled here, Okay, so how long it will go? It will be 2 seconds only, because the total burst time is only 2 seconds, so it will be 15 seconds. 13 plus 2, it will be 15 seconds. And you see, P4 has done its job. It has finished the execution. Alright, so now P4 will be removed from the queue. Now again P1 is there in the queue, so P1 will continue its execution, and it will continue until what? We have 16 more time to finish. Okay, but it will execute only for 5 seconds, that is the quantum. Okay, so 15 plus 5, 20. Okay, so how much time left here now for P1? It will be 11. 16 minus 5, that is 11 seconds left now. So I'll remove the P1 here now, and I will reschedule it after P3. Now P3 comes into picture. This will be scheduled now for execution. Okay, and how long it will continue? Because there is only 1 second to complete, so it will complete at 21 itself. And P3 has also finished its job. There is no time. Okay, so there is only one process left, that is P1 now, which is having 11 milliseconds left time. Okay, so it will complete its job until the completion, that is 21 plus 11, it will be 32 seconds. Understood? This is how every process in the ready queue will be executed for a fixed amount of time, the given amount of time here, the quantum 5. Okay, and if the time is remaining, so that process will be rescheduled again in the queue here for the execution. All right, so let us calculate the waiting time of every process here. Okay, so what is the waiting time? Completion time minus arrival time minus burst time. Okay, since there is no arrival time, yani we assume that all the arrival time is 0. So directly you can write CT minus AT here, BT here. Okay, what is the completion time of P1? When did it finish? It finished at 32. So I'm gonna write 32 minus, what is the burst time? 21. So 21. So what is it? 11 milliseconds. And what is the completion time of P2? P2 finished at 8. And what is the burst time? It's 3. So the waiting time for P2 is 5 milliseconds. And P3 finished at what time? At this time, 21. 21 minus, what is the burst time? It is 6. So it's going to be 15 milliseconds, right? Okay, now P4 finished at 15, and what is the burst time? It's 2, and it waited for 13 milliseconds. Okay, so average waiting time is what? 11 plus 5 plus 15 plus 13. Okay, so this divided by number of processes 4. Okay, so you can calculate this, add up all these and divide it by 4, you will get the answer. Okay, understood my point? Round robin scheduling. Let us take another example now. Let me